This is Mr. Reyes, principal at Tallahassee Elementary School. I'm wanting to share some further information about testing and test items. As you probably know, last year for the first time in the spring, grades 3 through grades 8 took the ACT Aspire. This will be the standardized test that the state will give each year again in the spring for grades 3 through 8. What I'd like to do is over the next several days and weeks is give you information concerning what test items might look like and how they're different from what maybe you and I saw when we were in school. So let's do this. I'd like to maybe start rather at the beginning. Let's start at the end and let's talk about grade 8 items, and then we'll work our way back all the way through grade 3 over the next several days and weeks. Now, what we'll do is we're going to take a look at a PowerPoint and discuss what a test item might have once looked like. When we were in school, we might have seen a problem such as this, which involves the Pythagorean theorem, which is on the course of study for 8th grade. And the problem might have said something like this. Find the length of side, and let me make a change there real quick. It should say side C in triangle capital ABC. All right, let me save that. We'll push play again. So we're looking at finding the length of side C in triangle ABC. So you see what we have is we have two legs, 8 and 10, and we have a hypotenuse C. Now if you'll remember back from school, what we would do is we would say again it's a squared plus b squared equals c squared. And with the, we would say a is 10 and b is 8. So we would say 10 squared plus 8 squared, that's 100, plus 64 is 164. And then, of course, that would be equal to c squared. And then if you'll recall, we'll take the square root of both sides, and the square root of c squared would just be c. And then the square root of 164, we could use our calculator, or we could also try to see if there were any roots within 164. But anyway, we could say very briefly that the answer would be c is equal to the square root of 164. Again, we could find that as a decimal, or we could look for roots in the 164. In either case, let's move on. And I want to talk about what a test item might look like now. And again, keep in mind what we just saw as a test question. Again, something that we might have seen when we were in school. So is there a difference between what we see now and what we saw then? Well, I navigated to a website, and they had some really good questions on a site that they had. And I want to go to a question, I think it's maybe the fourth question in the sequence. Yes, it's this one right here. Now, I want you to notice the type of question that you're seeing. You see here, it says, a map of Nelson County is laid out in the standard XY coordinate plane below, where the center of the county is at 0, 0. A cell phone tower is at 5, 4, and Esteban's house is at 10, -2. Each coordinate unit represents 1 mile. The tower's signal range is 10 miles in all directions. The strength of the tower's signal to Esteban's house depends on the straight line distance between his house and the tower. What is the straight line distance in miles between Esteban's house and the tower? Now, the interesting thing here about this problem is that we're going to revert back to the basic problem that we saw in the previous slide. However, as you see, this problem has a whole lot of reading and some comprehension that students are going to have to do, finding out what things are relevant, what things are not relevant, and how am I going to attack this particular problem. So again, if you'll notice, it says we want to find the straight line distance between his house and the tower. Now notice you have a tower here at 5, 4, and the straight line distance to his house is 10, -2. Now again, what you would have to make sure we understand is that if we came from this particular point and went straight down, took a right, and then right from his house to the cell phone tower, notice what we have. We have a right triangle. And when we have a right triangle, we can then, if we're trying to find the measures of sides, we could use the Pythagorean theorem. A squared plus b squared equals c squared, as we mentioned earlier in the earlier slide. Now, if you'll follow with me, if we started here at 5, 4 and counted down 1, 2, 3, 4, 5, 6. So the length of that side would be 6, and then as we go to the right, 1, 2, 3, 4, 5. So we have a side rather that's length 5 and a side that is length 6. Now let's go and we'll pull up, let me find my calculator. Alright, now what we will do again is the sides were 6 and 5, so 6 times 6, because remember it's a squared plus b squared equals c squared, is 36, and then 5 times 5 is 25. So we would take 25, add it to 36, and we would get 61. Now remember, that would be 61 is equal to the side that we're looking for, c squared, the distance from here to here. So we would say c squared is equal to 61. Now, as you notice, they don't have an answer in decimal form, but they do have it in radical form, which is the square root of 61. Now, of course, they could also have had it by trying to find some roots within 61. There are no roots, rather, in 61, so the answer would be square root of 61. Now, again, the point here being is that if we think about the problem in this particular example, we use the Pythagorean theorem in its most simple form. But we had to take information that we were given, which involved a good bit of reading, to actually get to what it was we were trying to find and what we would have to use to find the answer. So again, this is a problem that we would see from an 8th grade course of study talking about finding the Pythagorean theorem. And then let's go back and take a look again at what we would have seen when you and I were in school about using the Pythagorean theorem. Is there a difference? There certainly is. The difference is in rather just memorizing a formula, taking numbers and plugging them in, we go from something like this to something like this. It is a big difference. I hope this has been helpful. And again, what I would like to do is over the next few days and weeks is to kind of work our way back again from the 8th grade, because again, Aspire is grades 3 through 8, and we'll move down to maybe next time a 6th grade, then maybe a 4th grade and a 3rd grade and that type thing, just to kind of give you an idea of what your child will be seeing in terms of assessments and what types of problems they could possibly see on a test. I hope again this has been helpful and wish you the very best.